Section 3.4 and Section 3.5, Properties and Graphs of Rational Functions, Part 4. So now we are at the intercepts. I'm not going to do an example for that one. You'll see once we put everything together, we will find intercepts, but we've done plenty of those. Just remember x-intercepts, you said y to 0, and to find y-intercepts, you said x to 0. So let's go ahead and skip to part 5, behavior of graphs as x approaches the vertical asymptote from the left and the right. Example, find the behavior of the graph as it approaches the vertical asymptote. So in order to do that, we first must find the vertical asymptote. And if you remember, we do that by setting the denominator equal to 0. And then we find that the equation of our vertical asymptote is x equals 0. Now, in order to determine what our graph is doing as it gets close to the vertical asymptote, we're going to take an x that gets really close to 4 from the right and the left. So what happens as f of x approaches 4 from the right? I don't really like how that pink color looks because you can't see the words very well. So let's change it to yellow. So what happens to f of x as x approaches 4 from the right? And I wrote right underneath in blue how you read that, just so you know that positive, that little positive superscript means from the right. Okay, so what happens as x approaches 4 from the right? To picture that, what I'm going to do is I'm going to draw a number line here. I'm going to zoom in. I'm going to draw a number line. You see how I pointed my arrow this way? So I'm going towards 4 from the right. What does that mean? That means if I'm approaching 4 from the right, I'm plugging in a number infinitesimally close to 4 that's coming from the right. So the next number would be 4.000000001. That wouldn't be a number close to 4. So let's go ahead and do that. So we are plugging in numbers infinitively close to 4. So there you have it. I plugged into my function 4.001. Notice that on top, I just went ahead and plugged in 4. And the reason I did that is because the numerator is defined everywhere, right? It's only the denominator that we have trouble with. If I plug in 4, then 4 minus 4 is 0 in the denominator, and therefore undefined. And that's why I cannot plug in 4. And that's why we're looking at numbers really close to 4, just not 4. Okay, so what happens when you subtract 4.0001 minus 4? We get an infinitesimally tiny little positive number. And I said this before, any number over a tiny, infinitesimally tiny number is equal to what? Positive infinity. So that means that as x approaches 4 from the right, our function is getting closer and closer to positive infinity, and this is going to help us graph. Now let's do the same thing for what happens to f of x as x approaches 4 from the left. So that superscript negative, this is what I'm looking at, that negative means coming from the left. So if you're coming from the left, what number should we plug in? So now I'm looking at this here. Now I'm coming from the left. So I'm highlighting it so you know what I'm talking about. So if I'm coming from the left, what is a number you can plug in really close to 4 coming from the left? If you said 3.99999, many nines, infinite nines, then you are correct. So let's go ahead and do that. Let's plug in a number really close to 4 from the left. So as you can see here where I'm highlighting, I plugged in 3.9999. So if I subtract 3.999 minus 4, what do I get? An infinitely small, tiny little negative. It's so small. It's like negative 0.000, infinite zeros, 1. Right? So what do I get? Negative infinity. So as x approaches 4 from the left, and then I wrote notice I made a mistake here. I wrote equals -4. It doesn't equal -4. It approaches -4 because, I'm sorry, as x approaches 4 from the left, f of x approaches -infinity. We can never get to -infinity, and that's why it's not equal -infinity. We approach -infinity. Okay, so knowing the behavior of the graph as x approaches the vertical asymptote from the right and left helps us graph. In fact, you should now be able to graph f of x equals x plus 2 over x minus 4 because I gave you all the tools. So even though I didn't ask you to graph in this particular problem, we are going to do so just for fun so you can see that you already could graph these guys. So I'm just going to list all the information and then you're going to get the opportunity to do an example. So let's see what we can get out of f of x equals x plus 2 over x minus 4. Okay, so I'm going to highlight every time I talk about something so you can follow along. So on the left, take a look at the domain. You already know that this function is defined everywhere except at 4. That domain is also going to help us graph because then I can see where my graph is defined. Vertical asymptote, we already found that out above. Now horizontal asymptote, I'm going to do the shortcut just because I'm going through this fairly quickly, and then we'll spend more time when we actually do an example. So notice that the degree of the numerator is 1 and the degree of the denominator is 1. Because the degree is the same, the coefficient in front of these variables is our horizontal asymptote. So since the coefficient of x is 1 in the numerator and the coefficient of x in the denominator is 1, our horizontal asymptote is y equals 1 over 1, or just 1 simplified. X-intercept, you said y equal to 0, and you should get -2, 0. I don't know if you've noticed, but every time I find intercepts of rational functions, I only look at the top, and the reason why is because if you have a fraction, the only way the fraction could be 0 is if the numerator is 0. Okay, and then for the y-intercept, we said x equal to 0, and we should have gotten 0, -1/2. And then this last part, as x approaches 4 from the right and 4 from the left, we did it in this particular example. So we're going to use all this information to help us graph. So if you look on the right hand side, I already drew your intercepts. Okay, so I'm going to zoom in a little bit. So my x-intercept -2, 0, and my y-intercept 0, -1/2. Okay. I also have my vertical asymptote x equals 4 and my horizontal asymptote y equals 1. So we already did that. Okay, so how can we use the other information to finish graphing all of this graph? Well, let's take a look at the one that I just drew here. So I just drew this one here, okay? What I'm going to look at, I'm actually going to look at the behavior of my graph as x gets really close to 4. Now, on this side, what I did is I looked at my graph as 4 is approaching, x is approaching 4 from the right, right? We're coming from the right. So let's look at what happens as x approaches 4 from the right here. F of x is getting closer and closer to positive infinity. And that is how I know that I'm going up and not down. Because my graph could have also been maybe down here, but we're not approaching, f of x is not approaching negative infinity. F of x is approaching positive infinity. So I know that my graph is the top graph. Okay? One thing I didn't do is we didn't look at what happens to f of x as x approaches plus or minus infinity, and that would have been with the horizontal asymptote, and that's a good one to look at as well because then you can see the behavior of the graph from here. So for example, here the bottom part, as x approaches negative infinity, because this time we're going this way, f of x should be approaching 1, our horizontal asymptote. Okay. So now let's take a look at the other graph, the other part of the graph, because now I'm going this way, I want to see what happens to f of x as x is approaching 4 from the left. And we already did that, so let's go back over here. And now I'm looking at this part. It turns out f of x is approaching negative infinity, so I know my graph is going down. And then I also know that where my x-intercept and my y-intercept is, so that should have been a good indication where your graph is going. And you know, one of the things that we haven't looked at is whether the graph crosses the horizontal asymptote or not. And we're going to look at that in the next part, because again, there is a chance that your graph could have done something like this. Let me show you. So the green one's not the real graph, but it could have done something like this. That's a possibility. Okay, we could have crossed the horizontal asymptote. So let's see, how is it that we look at that? And you know, I think I'm going to leave the horizontal asymptote for the next part. So join me next time for, or not the horizontal asymptote, but join me next time to check how is it that a graph crosses the horizontal asymptote, or how do we check that it does. Thank you.